In this first lesson, we're going to be looking at the atomic model. And the first thing I'd like you to do is to complete this bubble map with any words that you associate with the atom. And once you've done that, definitions for the following terms: atom, element, compound, and mixture. These are all terms that you would have come across in year 7 and 8, and this should take you no longer than 5 minutes to complete. In green pen, you can add to your bubble map and make any corrections. So when we think about the atom, you might be thinking about its physical appearance. So perhaps that it's spherical, that they're very small. In fact, they're more than small, they are microscopic. Perhaps you're thinking more about where we find atoms. So atoms form elements, compounds, mixtures. You might have even thought of perhaps molecules, or perhaps you know a little bit about the actual structure of the atom. You might have something like protons, neutrons, electrons, shells, and the nucleus. So our definitions. So an atom. Now these definitions are really key. So make sure you make any corrections that you need to in green pen. So an atom is the smallest indivisible part of an element. So it's really important. It's indivisible. Now, what's weird about this is that atoms can be broken up. They can be broken down into smaller subatomic particles, but as soon as you do that, they are no longer an element. So when we're talking about atoms, they are the smallest indivisible part of an element, because as soon as you break it down into its protons, neutrons, and electrons, they're now subatomic particles. They're now no longer unique to that element. So elements are a substance that only contains one type of atom. So every atom in that substance is identical. So only contains one type of atom. A compound is a substance that contains more than one type of atom, and importantly, they are chemically bonded. So, more than one type of atom, chemically bonded, really important. And our mixture is very similar. It is also a substance that contains more than one type of atom. Actually, mixtures don't have to be atoms, they could also be mixtures of compounds, so we can say atom or compound that is not chemically bonded. So again, more than one atom or compound, but this time it is not chemically bonded. On this page we have some questions about the development of the atomic model. Now there's a video I'd like you to watch, and while you're watching that video you can be answering these questions. So each one of these questions will be answered in the first 8 minutes of the video. Now I wasn't able to embed the video for copyright reasons, but there is going to be a link which should appear about here. So if you want to pause the video, click on that link, watch that video and complete these questions, and then afterwards we'll come back to this video and I'll go through the answers. So I'm just going to go through the answers again, just make sure you correct anything you got wrong in green pen. So what did Thomson discover? So he discovered the electron, which is a subatomic particle that is negatively charged. In his experiment, what did he change and what did he measure? So in the cathode ray tube, he was varying the voltage. And he measured the deflection of the particle. And from that, he then calculated the mass. And determined that this particle was both negatively charged because it was being affected by the electric field, and that its mass was 2,000 times lighter than the smallest known particle, which was the hydrogen atom. So what model of the atom did he make? So he came up with the Plum pudding model. So in the Plum pudding model, they still knew that atoms had no overall charge, but now he knew that it had to contain these negatively charged electrons. So the model he came up with has the negatively charged electrons just randomly scattered throughout the atom. So randomly scattered negative electrons. But because he knew that the atom needed to have no overall charge, he proposed that there was a sphere of positive energy or positive charge. And that would balance out the charge, so overall it was neutral. So what did Rutherford discover? So Rutherford discovered that atoms were mainly empty space, and that's because those alpha particles he was firing at the gold foil, about for every 8,000 that he fired, 7,999 went straight through and didn't hit anything. However, some were deflected, and from the angles of their deflection, they calculated that there was something dense and positive in the center. So he discovered that atoms had a dense positive nucleus. So in his experiment, what did he bombard his gold foil with? Well, it was alpha particles or alpha radiation. Which, if there was anything solid with mass in the atom, they would have bounced off of. He was expecting all of them to pass through. If this model had been correct, they all would have passed through, no deflection. So the fact that most of them did kind of confirm that it was mainly empty space, but the fact that a small number did deflect back proved that there was a dense positive nucleus at the center of the atom. How was his model of the atom different to Thomson's? So in Rutherford's model, we've got the dense positive nucleus, and we have our electrons orbiting the nucleus like this. So we've got our positive nucleus, we have our negative electrons, and we have our orbitals. So how is it different? So mainly empty space with a dense positive nucleus, and electrons in orbitals. Whereas before, in the Plum pudding model, the electrons were randomly scattered and there was this sphere of positive charge. So instead of the sphere of positive charge, we have the positive nucleus, and instead of the randomly scattered electrons, we have the electrons in orbitals. So if an apple is the nucleus, how far away is the electron? It is 1 kilometer. Which again, if we think about the atom, mainly empty space. So a huge amount of distance between the nucleus and the electrons. Later on, what did he discover in the nucleus? Well, firstly, they discovered the proton, and then later they discovered the neutron. But that has been credited to his partner, Chadwick, which we will talk about a little bit later on. So again, any of those that you missed or got wrong, just correct in green. So here I'm going to draw and label the two models of the atom that you need to be familiar with. I'm going to start with Thomson's plum pudding model, and then I'm going to do Ernest Rutherford's nuclear model. So the plum pudding model, so what Thomson had discovered was that atoms contained these very small, very negative electrons. So this idea that atoms were just spheres made up of nothing else no longer stood up to the evidence. So they needed to incorporate the idea that these atoms must contain these very small, very negative electrons. And the model that Thomson came up with was the plum pudding model. And he proposed that the electrons were just randomly scattered within the atom. So if we just label them, randomly scattered electrons. And he knew that they were negatively charged. But he also knew that atoms had no charge overall. So if the atoms contained all these negative electrons, how come the atom itself didn't have a charge? So he knew there must have been something there to balance it out. So he proposed that the rest of the atom was made up of a sphere of positive charge. And this would balance out the negative electrons. Now, when Ernest Rutherford started his alpha scattering experiment, what he discovered was that this was in fact not true. So his main discovery were that when he was firing those alpha particles, most of them went straight through. So he discovered that the atom was mainly empty space, but 1 in every 8,000 was deflected. And by looking at the angles of those deflections, he found that actually they were coming off of something in the very, very center of the atom. So what he had discovered was the nucleus. So he knew that in the very center of his atom, there was a dense positive nucleus. Now, what he would later discover was that the reason why it was positive was because it contained protons. But at this point, he hasn't quite discovered that there are protons, just that there is a dense positive nucleus. And the electrons are no longer randomly scattered. He proposed that they were in orbit around the nucleus. So our negative electrons are in these orbitals. And again, these are negatively charged electrons. In orbitals around the central nucleus. So what I'd like you to do now is to make a double bubble map comparing the plum pudding and the nuclear model. Remember, you're looking for similarities and differences. So a double bubble map comparing these two models. So we're going to start our double bubble maps. We're going to have plum pudding on this side, and we're going to have nuclear on this side. So I'm going to start off with their similarities. So looking at both models, the similarities we have, they both contain electrons. They both contain something with a positive charge. Now they are different. I mean, the positive charge here is a sphere of positive charge, whereas here it's a positive nucleus, but they both contain something positive. And importantly, because they both contain something negative and something positive, they have no overall charge. So in both models, the atom has no charge overall. So let's start to look at the differences. So the nuclear model has a dense positive nucleus, which the Plum pudding model does not have. It also has electrons in orbitals, which again the Plum pudding model doesn't have. And remember, the other discovery was that the nuclear model was mainly empty space because the vast majority of those alpha particles just went straight through. So it is mainly empty space. So what's unique about the Plum pudding model? Well, it has a sphere of positive charge, which the nuclear model does not, and its electrons are randomly scattered. So those are the key similarities and differences, and it's quite common that you're asked to compare these two models, and it's really important that you don't just look for differences, you've got to look for the similarities and the differences. So if you could just correct in green pen or add to your double bubble maps with the things that I've added here. So here we have a timeline showing the discovery of the different subatomic particles and the development of the atomic model. Now, the only two real discoveries and developments you need to know in detail was the discovery of the electron by J.J. Thomson, giving us the Plum pudding model, and the discovery of the nucleus by Ernest Rutherford, giving us the nuclear model. So you don't need to know any details about the electron shells being discovered by Niels Bohr or of the neutrons being discovered by James Chadwick. But we do need to be aware that obviously neutrons were discovered and that shells were discovered, because when you look at any atomic models now, you'll notice that we don't use the nuclear model. It has developed from there. So we're going to start off with J.J. Thomson. Now, you don't need to know the dates, but it is useful to know the order in which the subatomic particles were discovered in. That you do need to know. You don't need to know the specific dates in which they were discovered. So it was 1897 was when J.J. Thomson had discovered the electron. And from that, he developed the Plum pudding model. So we should remember randomly scattered negative electrons okay, and you should be copying this down, and a sphere of positive charge. Okay, and then it wasn't until 1909 that Ernest Rutherford did his alpha scattering experiment, where he was firing alpha particles at gold foil, and he found that most of them went through, telling him the atom was predominantly empty space, but 1 in every 8,000 was being deflected off of something in the very, very center, and he discovered the nucleus. So we've got our positively charged nucleus, so our dense positive nucleus, and our electrons orbiting around that central nucleus. So we have our negative electrons in orbitals. So it wasn't until 1917 that the protons were actually discovered. So up until then, they just thought it was a dense positive nucleus. It wasn't until 1917 that they confirmed the proton. So in terms of the order of discovery, we've got the electron is discovered first, followed by the proton, which obviously tells us that the last subatomic particle to be discovered was, of course, the neutron. So between the development of the nuclear model and the discovery of the proton, Niels Bohr in 1913 had discovered that the electrons weren't just in random orbitals around the nucleus, they actually occupied different energy levels. And the higher the energy level, the further away they existed from the nucleus. So we've moved on to a slightly different model. We still have our positive nucleus, but our electrons now, rather than being in random orbitals, they are now in what we call shells. Okay, so each shell gets further from the nucleus, and we still have our dense positive nucleus. And our electrons exist in these shells. This is referred to as the planetary model. So we've got our plum pudding model, our nuclear model, and our planetary model, because it's very similar to the sun and the planets and the way they orbit. Okay, and it wasn't until 1932 that James Chadwick discovered the neutron. So obviously this model was put together before the proton had been discovered. So between this model and here, we now have electrons, protons, and neutrons. We finally have all three subatomic particles. And the neutrons were discovered to exist within the nucleus. So we have in our nucleus, rather than it just being a dense positive nucleus, we have protons. And we also have, for the first time, neutrons, and orbiting around in shells we have our electrons. So to bring that all together, so we have our nucleus, we have our shells, and we have our negative electrons in the shells, we have our positive protons in the nucleus, and we have our neutrons in the nucleus. And as their name suggests, they are neutral. So make sure you've got that copied down in your pack. So now we know about the three subatomic particles, we need to know three things about each one of them. You need to know their relative mass, their relative charge, and the position within the atom. Okay, so you don't need to know their actual mass in grams or kilograms because they're very, 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 very small. So they've got very, very tiny mass. So we use the term relative mass. Okay, so a proton has a relative mass of 1. A neutron weighs the same as a proton, so it also has a relative mass of 1. And if you remember back to the very first video, the electron that was discovered by J.J. Thomson was 2,000 times lighter than a hydrogen atom. Now a hydrogen atom essentially is just a proton, so an electron is 1 over 2,000. So it's 2,000 times lighter than a proton. So their relative charge, now we already know that the proton is positive, and it is positive 1. If you just put positive, that wouldn't be correct. If you just put 1, that wouldn't be correct. It has to be positive 1. Neutrons, as their name suggests, are neutral. They have no charge. And there's electrons that are negative, and they are negative 1. So their position within the atom, your protons are found in the nucleus, your neutrons are found in the nucleus, and your electrons are found in the shells orbiting the nucleus. And what we can see there is that when it comes to the mass of the atom, well, it's only really the proton and the neutron that's going to contribute to the mass of the atom, because the electron is so light and so small. You would need 2,000 of them in order to increase the mass by 1. Well, the largest atom on the periodic table only has 118 electrons. So the electron's mass is what we call negligible. They're so small, they're so light that they have very little impact on the mass of the atom. So if you're looking at the mass of the atom, we only need to look at the mass of the protons and the neutrons. However, if we're looking at the charge of the atom, and we should know that atoms have no charge overall, then we're looking at the protons and the electrons, because it's the protons and the electrons that are the charged particles. And we should know that if the atom has no charge overall, and protons are +1 and electrons are -1, then if we know the number of protons, then we know the number of electrons. So we need to know these relative masses, these relative charges, and their position within the atom. But when you're looking at the periodic table, you'll notice I've got a image from carbon, but if I show you the periodic table, you'll notice every single element you are told the same information. You're told its chemical formula, and you're given 2 numbers. Now, those 2 numbers have names. So we have the bigger number, which is your mass number. And we have the smaller number, which is the atomic number. And we have the chemical symbol. So the chemical symbol simply tells you which element it is. So all elements have a unique chemical symbol. But the atomic number and the mass number, they tell you something in particular. The atomic number is equal to the number of protons. So carbon here has an atomic number of 6, therefore has 6 protons. The mass number is equal to the number of protons plus the number of neutrons. So here for carbon it is 12. Now that's useful because we will always be given the mass number and the atomic number. So if we know the atomic number is 6, so there are 6 protons, and the number of protons plus neutrons is 12, if we do the mass number subtract the atomic number, we will know how many neutrons we have, which in this case 12 minus 6 is 6. So we've got 6 protons because the atomic number is 6. We've got 6 neutrons because 12 minus 6 is 6. And the last subatomic particle is the electrons. And if we remember, the atoms have no charge overall. So if I've got 6 positive protons, I must have 6 negative electrons. So an atom of carbon has 6 protons, 6 neutrons, and 6 electrons. Now, the number of protons and electrons has to be the same every time, but the number of neutrons doesn't. Okay, coincidentally here it is 6, 6, and 6, but you'll see the more examples we go through, the number of neutrons isn't always the same as the number of protons, and it doesn't have to be. So you always, if you want to know the number of neutrons, it is the mass number subtract the atomic number. If you want to know the number of protons, it is simply look at the atomic number, and if you want to know the number of electrons, it's the same. Look at the atomic number, because the number of protons will always be equal to the number of electrons, provided you're talking about an atom. So below, there are 3 questions about how can we work out atomic structure from the periodic table, and then there are 5 examples of atoms of elements where you need to work out how many protons, neutrons, and electrons there are in each. This should take you no longer than 5 minutes. So I'm just going to go through the answers to these questions. Again, make corrections in green if you need to. So how can we use the periodic table to find out the number of protons in the atom of an element? So the atomic number is equal to the number of protons. And remember, the atomic number is the smaller number. You're always given two numbers. The smaller number will always be your atomic number. How can we use the periodic table to find out the number of electrons in an element? So, because the number of protons is equal to the number of electrons. So if we know the number of protons from the atomic number, then we also know the number of electrons, provided it's an atom, because atoms have no charge overall. And how can we use the periodic table to find out the number of neutrons? It is the mass number subtract the atomic number equals the number of neutrons. And again, that's because your mass number is your protons plus your neutrons, whereas your atomic number is just your protons. So if you take the atomic number away from the mass number, you are left with the number of neutrons. So we had 5 examples. So for all of them, I'm going to do protons first. So sodium has an atomic number of 11, so it has 11 protons. Fluorine has an atomic number of 9, so it must have 9 protons. Magnesium is 12, so it has 12 protons. Oxygen is 8, so it has 8 protons. And argon is 18, so it must have 18 protons. These are all atoms, so they must have the same number of electrons as protons. So 11, 9, 12, 8, 18. And to get the neutrons, we just have to do the mass number subtract the atomic number. So 23 minus 11 is 12. Notice that is not the same as the protons. It doesn't have to be. Double check it every time. 19 minus 9 is 10. 24 minus 12 is 12. So here they are the same. Sometimes they are, sometimes they're not. You just have to do the mass number, take away from the atomic number. 16 minus 8 is 8, and 40 minus 18 is 22. And there we can very quickly, just from these 2 bits of information that you're provided with on the periodic table, and you will always have a copy of the periodic table available to you. There's one in your planner. If you look near the back pages, there's a copy of the periodic table there, and you will always be allowed to use it as well. So in chemistry, whether we are talking Key Stage 3, GCSE, A level, or at degree level, you will always have access to a periodic table. So you've just got to be able to read it and understand it, and you can get all of this information from it. So here you have a 10-question facts test. All of these questions relate to this topic, and particularly to the stuff covered in this particular lesson. So you have 10 minutes to complete that facts test. So as we're going through this, just make sure that you're correcting your answers in green, and you're going to give yourself a score out of 10 at the end. So first one, where are electrons found in the atom? They are found in shells. How many electrons does an atom of oxygen have? Well, we're going to need a periodic table for that, which you have in your planner. So how many electrons does oxygen have? So we need to look at the atomic number, which is 8, which tells us it has 8 protons, which tells us it therefore has 8 electrons. How many protons are in an atom of carbon? So again, we need the periodic table. Atomic number is 6, so it has 6 protons. What name is given to a substance that contains more than one type of atom chemically bonded? So that is a compound. Where are neutrons found in the atom? They are found in the nucleus. What is the relative charge of a neutron? It is 0 or neutral. What name is given to a substance containing only one type of atom? That is an element. Name two features of the Plum pudding model. So we could have a sphere of positive charge. We could have randomly scattered electrons. Or we could have no overall charge. Those are your options. So any two of those. How many electrons does an atom of calcium have? So we need to find calcium. Atomic number is 20, so it's got 20 protons, which means it's going to have 20 electrons. And what is the relative mass of a neutron? Well, the relative mass of a neutron is 1. So correct any of those that you got wrong in green pen and give yourself a score out of 10.